Okay, we're going to do number 92. So let's take a look at that first. Number 92 says, what are the coordinates of the point on the directed line segment from -5, -4 to 5, 1 that partitions the segment into a ratio of 3 to 2? So I actually got a little graph paper thing here, which might make this a little bit easier, maybe. So let's draw our coordinate plane. And then let's label our points. The first point is at -5, so -1, 2, 3, 4, 5, and then -4, 1, 2, 3, 4. So this guy right here. And then the other point is at 5, 1, 1, 2, 3, 4, 5, and then 1, which is right here. So if we draw our line segment, it goes from here to here. And it wants to know where we can draw a point to separate it into a ratio of 3 to 2. Now, it's really important to remember two things. One, we're going to find the distance of this line. And then two, we're going to break it up into this many parts. So if we have 3 parts on one side and 2 parts on the other, that means to make this as easy as possible, we want to break this line up into 5 equal parts, because then we can just count 3 and 2, and it's really, really easy. But before we do all that, let's find the distance. I'll do this one black. We do from here to here. This is how I find the distance. I use the Pythagorean theorem. You can also do distance formula. It is exactly the same thing. It works as well. I just like to do it this way. So this distance right here is from -5 to +5. So that's 10. I mean, you can just count. You can count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, same thing. And then this distance right here goes from -4 to +1. So that has a distance of 5. Again, that's just me counting. Now, the reason I do that is because I'm going to do Pythagorean theorem. This is obviously a right triangle. You can see that as indicated here. We drew it so that it was a right triangle. You guys know how to do Pythagorean theorem. So that'll be 5 squared plus 10 squared equals c squared. And then you take the square root of that, and you get 5√5. Let me make sure that that is double check. Yeah, you get 11.81. You get the square root of 125. So you do maybe have to calculate that out. But I got the square root of 125, which when you break it down is 5√5. And now that actually works really, really perfectly, because 5√5, remember, we're trying to get it into 5 equal segments. Well, that's easy. That's just √5 plus √5 plus it is √5 is when you divide that by 5. So I don't know if I have a square root button on here. I wish I did. I'll just draw it. It's fine. So remember, that's just √5 plus √5 plus, I skipped the root there, plus √5. Now, the reason we're doing this is because we want to break it into a ratio of 3 to 2. So I want to do 3 of these on one side of the line and 2 of them on the other. I want this to be where I divide, this to be one side of the line, this to be the other. So in order to do that, I can just really easily count. 1, 2, 3. This ratio, sorry, I didn't really explain that well while I was talking. The reason I know that that's the right point to break it into 3 versus 2 is because if you follow that pattern established from the 5 and the 10, you're looking for 2 triangles that are, you know, this side is half as big as this side. And if you look at it this way, when I break it up into these two triangles. This side is 2. Really having trouble here. And this side is 3. And so I know this side is going to be 6. And this side's going to be 4. And so I broke it up into 5 equal pieces, 3 on this side and 2 on that side. So this point right here is my point. That's the answer, which is 1, -1. So that 0.5 thing, make sure you know, like when you're doing a ratio of 3 to 2, you're looking for 5 segments total that break up 3 of those segments on one side and 2 of those segments on the other. This right here has a distance of 3√5. And that is exactly how we calculate that, whereas on the other side, it has a distance of 2√5. You can do Pythagorean theorem again to check that, but all you're doing is making it so one side is 3 units, the other side is 2 units of equal length. So kind of a weird question, but not too difficult.